So here's an example of vertical circular motion with calculations. A string is attached to a center O at one end and a particle P of mass 6 kilos at the other end, where OP equals 2 meters. The particle is struck with a speed of 12 meters per second horizontally. Find the tension in the string when the string makes an angle of 30 degrees from the horizontal. You just got to remember that you use the conservation of energy equation with the centripetal force equation to solve this. So go ahead and try this problem, and when you're ready, come back for the solution. So here's a little diagram of what's going on. So we have our particle at P struck with initial velocity 12 meters per second. When it's at this point, 30 degrees from the horizontal, these two are similar triangles, so the angle will be in the same place. So we have the tension acting inwards, and we have the component of the velocity acting out, which is cos 30. So the net centripetal force will be T minus mg cos 30. When it's at a height, or when it's reached 30 degrees, the height of the particle above the horizontal is 2 minus 2 cosine 30. So 2 cosine 30 is this little adjacent side. I'll just mark it. So this length here is 2 cos 30. So this is that height here, 2 minus 2 cos 30. Now for the maths, the centripetal force is mv squared over r. So T minus 6g cos 30 is mv squared over 2. So multiplying by 2 and simplifying, we get 6v squared is 2t minus 6 root 3g. Now we have the conservation of energy equation. So initially it's at no height, so there's no potential energy, but there is kinetic energy. Then, of course, the height is 2 minus root 3, which is just 2 minus 2 cos 30 simplified, plus a half by 6v squared. So we have an expression for 3v squared, but if we multiply by 2 and simplify, we now have an expression for 6v squared. So we can put the expression here for the 6v squared, so this entire thing, into 6v squared. And solving for t, we get a tension of 467 newtons.